Okay. All right. So this morning, slightly different to how we've done. Well, there's a lot of similarities, but so far these lectures, what I have done is kind of shown you some stuff. And last week, we basically ended the first task, which was importing things into Rhino or importing data into a digital environment of whatever kind. And you had a little task to do, which was to put together and overlay some information from some kind of source to do with your site. Just give me a little wave if you've cracked on with that task, if you at least started it. Yeah, great, wonderful. So the majority of you have had a decent go at that. What we're going to do this week is I am going to give you some input. I'm going to talk about a few different things to do with some really important vocabulary in the digital, which is about how we control these digital files and how we make sure that they aren't things that completely sort of explode out of our control, and how we can keep our file sizes kind of nicely tamed. But the main purpose of this morning is to say this is an opportunity for you to ask questions, for you to ask a question on anything to do with the mapping task, anything to do with the import that we've already done, and the data that you've started playing with. And anything to do with the modeling part of the course that we've just started. Anything to do with the second task, which is a really simple one, which is simply to make a 3D model using a piece of software. I would sort of nudge you towards Rhino, and I'll be teaching using Rhino, but you could use a different one if you wanted to, of an object that you find on your desk. So desk at home, desk in the studio, whatever it might be, find a thing, you're going to make a model of it. That's basically it. And at the same time, think I can also, hopefully you've all got that QR code so you can start asking questions. This should be working, right? Is that taking you through to the right place? Good. At the same time, if you have anything that you want to put on the screen to talk through, so rather than just a question, this is actually something where you want to say, oh, well, this is what I'm working on at the moment. You could have taken a screenshot. You might have got a work in progress version of something. You might have taken a screenshot of some modeling that you've done and saved it somewhere. Then you can do that using, I believe, the university has access to Miro. There's obviously something wrong with the projector going on here. Seemingly everything is going wrong. Here we go. I believe it's possible for you to log into Miro with your Brooks account. And then you can simply chuck stuff up onto a board. And the idea is that this is like a sort of a help session as much as possible. Come on then. For some reason, we've decided to be very slow today. Oh, there we go. Here we are. This is just going to be a blank board. You can put whatever you want there. And chair 15, 10, 20, 25. Come back to here. Oh, well, that isn't very good, is it? I think should be able to do it. Oh no. Yeah, there you go. It's a slightly smaller link. It's still a little bit long, but there we go. So the title of that is the Miro link, and then you can put anything you want on the Miro board. What I'm going to do is, how many people here can multitask? Probably not many. We're all architects. We want to do one thing at once, right? So what I'm going to do is I'm going to leave the questions open. I'm going to leave the Miro board open. So you can put any question you like on there. The first kind of half an hour, I'm going to talk through some things on Rhino, and you can put some questions on, chat with the person next to you about those, about what you want to ask. It looks like there's already 4 questions. Amazing, brilliant. And I fully expect it's absolutely fine. It's not cheating to say, I want to model this. I don't even know how to start. Can you give me some pointers? And we'll get going already this morning. That's absolutely fine. I'm very happy to do that. So it's fine to ask the question, I want to model name a thing. And we'll have a little go, and this is all recorded so you can watch it back and you can kind of get a leg up on that process. Okay? So, one of the things that I spoke about a little bit last week, but I want to go into a bit more detail and demonstrate why this is so important, is this idea of the number of control points that you put onto your scene. We're already quite familiar with this idea that these things, after a while, if you're looking at something and it's just like totally black with lines in wireframe mode, that's probably a bit of a bad situation. And this is one of the main reasons why I tend to delete the more sort of detailed people, because they are a slightly larger file size, and I don't really need them right now. I can use my low poly guy called Gary, who has far fewer control points, and that is going to make sure that my file is as swift and fast as possible. Now, there's some psychology around this, and I'll sort of try and demonstrate this. But if you are working on a model and it moves slowly, maybe over the summer task, did anyone find that they were working with a model and like as they tried to kind of readjust their view, it would kind of go dum, 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 like very slowly or sort of jaggedy? Yeah, I've got some knots. What happens in your brain when you're working with something like that is that you're not then thinking about how do I design this well. You're just sort of like enter this sort of weird fugue state where you're just looking at the digital. And what you really want is a kind of a speed and a flow in your digital file, which you only get by keeping the file size quite low and your geometry controlled. And the word here, the most important word, is this idea of control. So in Rhino, we have these things called control points. So I can make a control point curve. This is exactly what we did last time. There's 3 control points. I've just literally just put down 3 points on the ground. And I can do the same thing again. Boop, boop, boop. There we go. Another 3 control points. And I'm kind of looking from above. And maybe this is kind of a nice idea of a plan view of some kind of like weird little pavilion-y tenty thing. I don't know. And I can press F10, which is what we looked at last week. And I can grab some of those control points. And actually, I just want to grab the middle ones. And we'll sort of drag them up like this. And now we've ended up with this kind of shape. And I can start to sort of play around. And maybe this one sort of stands up in the air. And maybe this one kind of goes up in the air. Who knows? And then, when I'm happy, not sure how this is going to turn out, but I can select all of those and I can type loft, and it will make a nice, smooth, curved surface that goes between these lines. And you can imagine that in lots of ways, basically, I could have picked any lines, any number of lines to make that surface. I'm going to switch over to ghosted mode so I can see the actual sort of physical surface of this. And already there's something kind of quite nice about maybe this view. There's kind of this opening. This is kind of we're designing with the digital. Do you see how sort of fluid and smooth everything is? I'm kind of not really having to second guess any of my decisions because I'm working at the speed of my hands, much more like sketching. Now, I sort of demonstrated this last time, but one of the things that people tend to do when they think about this idea of control is they think, well, my line must go here. Like that's what I think of control is a kind of a very normal beginner statement. It's like, I want to control my lines so they go where I want them to go. And with control points, it feels a little bit more loose. It's like you're using these kind of magnety things to steer the lines around. So what you end up doing is you realize that, if you really want a line to go in a particular way, you can put loads more control points down, and then it'll go kind of roughly where you want it to go. But you see how many times I've clicked that in order to get that line where I want it to be. And, maybe I've got another one that I want to go somewhere like here, and then maybe this one's going to go in a sort of funny wiggly state. Now, there's a few things that are going to go wrong here. So the first one is that I'm going to turn on my control points, and maybe I want to change how this looks. So I do the same process. Well, now I've got a lot more points to try and move around. And it's going to get pretty messy pretty quickly because I have to be quite careful about which ones. Oh, I've missed that one, and that one's going over here. And maybe this one's going to go up here, and maybe. But now suddenly, instead of 9 decisions, I've got like 53 decisions to make. And it's going to be quite difficult for me to create this anything like a kind of fluid, sort of simple surface. And then I want to sort of demonstrate this. I've taken these curves in exactly the same way, and I'm going to loft them. And for a start, obviously, we get this kind of a lot more. I mean, you might find that quite an interesting shape, but there's a lot more of these black lines. These black lines are effectively, they're called ISO curves, and they're effectively saying this is how much data Rhino needs to have about this surface in order to represent it. With this one, basically, a couple of lines, I'm done. With this one, suddenly I've got loads and loads and loads. Where this gets really, really obvious is if I select this, or did this last week, I'm going to offset that surface to make it thick. Maybe 100 mil, there we go. And already, do you see how it's multiplied up the number of those black lines in order to create that surface that has thickness? If I do the same with this, the number of black lines becomes much more complicated. And you can end up seeing this in an exponential way. I've just done exactly the same, function again, which is I've just selected that surface, that poly surface, and I've offset it. And it's created this kind of quite complicated thing. If I do the same here, it's done in like no time at all. I'll just demonstrate that one more time. So I've offset that surface, and it's already a lot more complicated. I'm going to offset this surface again, and just watch how long my mouse takes. Spinning, 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 thinking. Oh, there we go. I'm going to do the same for this one, same exact thing, and it's done. And that's because on one of them, I started with only 9 control points. On the other one, I started with 75 or something. And so what happens is, as you increase the complexity of your model, you go into more and more detail, the decisions you make right at the beginning have an exponential impact on how nice your model is to work with by the time you've actually done it. The other thing is that if I export, I'm going to select this model, I'm going to export it to just my desktop for now, and I'm going to say this is the heavy model. It's thinking, there we go. I'm going to select this one, I'm going to export that, and this one's the light one. Didn't take anywhere near as long. I'm going to go to my desktop. The light one, 1.3 megabytes. Heavy one, 24.7. So in one of those situations, I started with far fewer, but I've ended up with 25 times as much of a file size. Anyone who was using Rhino or 3ds Max or anything over the summer, did you find that your file weighed was really large by the time you finished? Yeah? Probably this is why. So you can have complex, interesting geometry with a very small file size by keeping things under control. So when we think about control in a slightly more mature way, rather than this is where my line needs to go, the answer to that is really to paradoxically reduce the number of control points. Now, I'm just going to come back to these lines. The other thing about this is that I wonder if I can do this. I'm going to do this one more time. Whoop, there we go. The other thing is that these things multiply up exponentially with the number of curves that you try and loft. So if I loft these curves, even before I start moving them around, I've got tons of these kinds of things going on. And then actually what I'm going to do is this is already just a massive mess, isn't it? So points. Just going to start randomly moving some of these guys about. Ooh, ooh. This is already taking far too long. There we go. And on the one hand, have I got control over this? Well, it's gone where I want them to go. But really, this is a kind of sign that we're out of control. Because if I now loft these curves, I'm getting that same situation where I've just got black lines everywhere. That kind of thing, where these lines are so close together that really you're just looking at kind of black. I'm going to do exactly the same thing, offset twice. So I've just done exactly the same thing, offset twice, basically. Made a curve, lofted some curves, offset them twice. And with this one, all I've done is multiplied up the lines by a few. So I've added more curves to my loft. It's still thinking. Oh, there we go, just about. Okay. So I'm going to select that. I'm going to export it. Oh, well, I don't want to delete the object. Why has it deleted it? There we go. Export. And this is going to be ultra heavy because it's not just lots and lots of control points on the curves, it's lots of curves. So it kind of multiplies up again and again and again. Successfully saved the file. Let's see how big this file is going to be. 84.9. So your file size is completely in your control. The rule that I tend to use, and completely up to you if you want to follow this, but my recommendation is, if I draw a curve in Rhino, I try as much as I can never to use more than 4 control points. And if you want a complex shape, here is the way to do it. And it's sort of inspired by the Snow Hetta Reindeer Pavilion. Have you seen this project? Beautiful, beautiful project. It's a pavilion in, I think it must be Norway somewhere, because Snow Hetta are a Norwegian practice. And it's this kind of beautiful sculpted bit of timber, and the seats kind of come out of this shape. And then it's a pavilion for watching reindeer on the plains of Norway. Like really, really lovely project. And you can kind of see it here. It's this kind of like quite simple square outside, but the inside has this really interesting shape to it. And that, you look at it and you think, oh, that's quite complex. I'm going to need to draw loads of curves to get that kind of shape, right? Well, what you do is, if we were going to build a reindeer pavilion, I'm just going to move my guy over here, and we'll kind of think about him. He's watching some reindeer, and we're going to start off with a curve that maybe kind of comes around here like that, and maybe I'll change my mind. I want this to be a little bit, I want this to be a little bit more pronounced. This comes out and then back in. So I've used 4 control points there. And that's kind of my ground line. And then what I can do is I can say, oh, okay, well, I'll copy, which we remember we just used the gumball and then tap the Alt key and we make a copy of that curve. And we'll bring that up a little bit, maybe back a little bit. I'm going to start with just 3 lines with 4 control points each. And then I'm going to do 1 more of those and bring it up to the kind of ceiling. Now I can make a loft. And you think, well, yeah, okay, but that doesn't have anywhere near the kind of complexity that the shape that I'm trying to create has. But this is the cool thing about these curves, is that each one of these curves is made up of 4 control points. And so what we've got is 4 times 3. We've got 12 points along here. And this surface is basically interpolating between my 3 curves. And when I say interpolating, what I mean is, just imagine a curve. In fact, I can even demonstrate this. Here are 2 curves. If I type in tween curves, and I want, like, I don't know, 50 of them, each one of these 50 curves kind of blends between the 2. All the surface is just a multitude of curves. So tween curves and making a surface, it's kind of, they end up giving you the same kinds of things. So if this surface is made up, this lofted surface is made up of like an infinite number of curves, you can actually extract that curve from the surface and then use it to create a slightly more interesting surface. But that curve will be in exactly the right place that you can start to massage that geometry. I'll show you what I mean. So I'm going to type, I've selected the surface, I'm going to type extract isocurve. Extract isocurve. And what that will do is it will turn my mouse into something which can extract a curve that sits exactly along that surface, or I can toggle by pressing this button up here, or just hitting T for toggle, and then enter, and I can go the other way. And then I say, well, actually, I want this to be a kind of a seat, so I'm going to take 1 line here and 1 line here, and then press enter. And now I can delete that, and I've got these lines, they're sitting exactly on that curved surface that I just created. But I might say to myself, well, actually, I want to pull up these couple of little bits here so they kind of form a seating area. And maybe that goes up to about there. And then this one, maybe these two lines, maybe they come a little bit more like that. And then do you see I'm going to start at the ground, I'm going to go up, and then this is going to be this seat, and then it goes up again, and then it goes to the ceiling. And in fact, actually thinking about it, it might be useful even to have something that kind of curves that, but we'll come to that in a second. So I've deleted the loft. I extracted the ISO curves that I wanted to make my surface a little bit more interesting. I deleted the loft, and then I can loft it again. And now, instead of a really, really simple surface, I've ended up sort of pinching and forming it in a way that feels like I'm kind of using like clay or something. Does this sort of make sense? And the great thing about this surface is it's super clean. There aren't any of these like crazy black lines because I'm starting with a simple surface and I'm just adding complexity where I need to make it. Let's do a similar thing, extract ISO curve. This way of working, by the way, is like, this is how I really like to use Rhino. So especially to make architectural kind of forms. Maybe these two lines here are going to come down and back a little bit. And then these two control points here are going to come up and back a little bit. I'm not sure how that's going to end up going. Maybe I want to move this one back just a little bit more. There we go. Could be quite interesting. And now you see how many lines I've got. I've got the same kind of 9 lines that I had in my example, which ended up with an 85 megabyte file. But because I've extracted them from the really simple surface, this is going to be much more controlled. There we go. Let's loft again. And now suddenly I'm starting to get into a place where I can imagine someone sitting here and then maybe some children sort of running around on this little ledge bit, and they're watching the reindeer and they're having a lovely time. So this is how control works in a digital sort of world. Any questions on that? Has what I've just sort of demonstrated made a bit of sense? Yeah. So a surface has an X and a Y coordinate. You can go along the surface up and down, or you can go along the surface kind of left and right. And when you type extract ISO curve, it gives you some things in brackets. And at the moment, this says direction V and then toggle. And so as I move my mouse around, my mouse is kind of highlighting that I'm going to extract a curve that goes across. Now, if I want a curve that goes the other way, and in fact, the first time that it loaded, it was doing this way. I can basically just toggle between the two. So I can just keep on pressing toggle, and it will give me one direction, another direction, one direction, another direction. Yeah. Now, yeah, this direction, in this particular way of me modeling, that direction isn't particularly helpful to me because all of my control curves that I'm using for my loft are kind of going in a horizontal direction. So I can kind of toggle until I find them. Now, it is possible. You can go click direction and choose both, and then it'll create this kind of like 2 lines that meet wherever your mouse is, like one in this direction, one in the other direction. I don't tend to use that very much, but choosing one of these is kind of, that tends to be how I would generally tend to work. So what I'm doing is I'm kind of starting with something basic and then working into it rather than starting with the finished product. Other questions on that? Cool. Do you feel like adding to the challenge that we've given you to model something on your desk, what you could also do is now think to yourself, if I start modeling something on my desk and it ends up being just a mess of black lines, maybe I need to take a step back and think about making something simpler to begin with and then working into it, rather than starting with all of the crazy little details. Okay, great. That's a challenge. Couple of other things that I want to show you on this. One of the tools that is going to be really helpful for you when you're modeling objects is linked to the way in which objects are actually manufactured. So I don't know if you've already started this task, what you'll start noticing is that there are sort of often certain shapes that come back again and again and again. And there are often certain things like seams and joins that you think, like, well, why is there a line there? Why is there a seam there in this little plastic thing or whatever it might be? And the answer is often because of the way it was manufactured. One of the ways that things tend to get manufactured is on things that spin. So if you're looking at something like pottery or ceramics, well, they are thrown on a spinning wheel. And what you do when you're making pottery is you put a piece of clay on a wheel and it spins round and you kind of like shape it, but you shape it just using your hands, right? If you've ever used ceramics or done pottery or seen anyone doing pottery before. And what you end up with is then a circular object. It like has an axis of rotation in the middle. Similarly, lots of things are made on a lathe, and there is one in the woodworking shop, I think, in the architectural workshop, which is basically you start with a piece of material and you spin it very, very fast, and then you cut into it with some kind of tool. And so things that are circular are everywhere around when you start looking for them. One of the things that kind of like is a really useful little exercise to do is to say, oh, can I make, I don't know, like a mug or something? Because it has a circular element to it, and it also has something which is like a handle, which is not, doesn't have that same circularity. What I'm going to do is just very quickly kind of demonstrate that there's a tool in Rhino that replicates this circularity, and it's called the revolve tool. What we're going to do is if I just type revolve, what it'll ask is say select curves to revolve. So we know we're going to need some curves to revolve. So the first thing is I need to draw some curves probably. So let's draw a few curves. I might do some polylines in this case. Maybe I'll start on the floor over here, and we'll go out to the left. Boom. And this is going to end up being the wrong scale. But anyway, I will zoom out here. Well, this is going to be really big. Okay, I'm just going to change my mind about that. This is going to be huge. Boom, there we go. Keep that nice and... just going to fix this. Project to C plane. This one here. I drew it on my front viewport, but I don't know if you can tell, this point up here is kind of like janked off to the side. And the reason for that is my front viewport has a different construction plane to my perspective viewport. So actually what I'm going to do is I'm going to come back over here. I'm going to find the center of my file. I'm going to work there because it makes it a lot easier. And I'm going to say, okay, I want to go sort of roughly somewhere here, and we'll go up like that. So I'm going to end up, what I've done is I've made this kind of like bowl or cup shape, but only half of it. Only the half that's kind of like one side of an axis. And then I'm going to draw a line that goes from this middle point up into the sky. It just goes up into the sky. And if I select that and then go over here, and I can just see this in 3D. So this line here is going to become my axis, and this line here is going to get revolved around that axis. So I'm going to type revolve again, and it says select curve to revolve. I'm going to select this curve, press enter when done. Start of revolve axis. So I need to have my snaps turned on. Oh, snap. I'm going to use the end snapping here. I'm going to go from the start of my axis down here to the end of my axis, which is up here. Boom. And then my mouse becomes this kind of like quite complicated thing. But what it's doing is my mouse is now allowing me to revolve that line around in 360 degrees. Do you see where I'm going with that? So I'm going to start at 0 degrees, and I'm going to click there, and then I'm going to drag out, and now I'm dragging this shape round in a circle. Yeah? Is this kind of fun? I can go all 360 degrees and then come all the way around back to 0 again, and then click, and I'm done. Press enter, and I'm done. And so now what I've got is this kind of like cup shape, which I got from just drawing the line that if you imagine you were a potter. Anyone done ceramics? Like maybe in art or something? Yeah? And basically you move your hand in a particular line on the wheel, but like I drew that line that I would move my hand in on the screen, and then I decided on the axis, and then it allowed me to rotate that shape around. Now this thing here doesn't have any thickness, so it might be really interesting to then go, oh well, what if already it's maybe a bit thick and squat, so I'm going to bring that in a little bit, and then I'm going to take this and I'm going to offset that curve just using the offset tool. And we're going to go, how thick is a mug? I don't know, what is it, like 5 millimeters, something like that? No, that seems a little bit thin. Let's go 7. There we go. And I've offset that curve, just like you would do in CAD. And then I'm going to put a line in between that top and that bottom, those two ends. There we go. And now it's open at this end, and that's okay because we're going to revolve it around that axis. I'm going to join that curve together so it becomes one continuous curve. Whoop, there we go, like that. Now, if I do my revolve tool, I'm going to revolve this curve, press enter when done, start of revolve axis, end of revolve axis. I'm going to, literally all I'm going to do now is the start angle I'm going to leave at 0, so I'm going to press enter. The revolution angle is 360 degrees, so I press enter, and then I'm done. And now I've got this 3-dimensional thick kind of mug shape. And you think, oh, okay, great, but what about the handle? Well, another really cool tool, as well as the revolve tool, is we could type in, first of all, we're going to make a curve. I'm going to use my front viewport, so I'm going to kind of be drawing on the middle of this thing here. I'm going to draw a handle. And remember, my rule was, or my self-imposed rule was, if you can get away with only using 4, at the most maybe 5 control points on your curves, everything will be much better for you. Maybe we want to bring that in a little bit like that. This is kind of looking quite cool. I like this mug already. And I'm not worrying too much about how exactly it meets it. I'm just working in this front viewport. And you can see I'm drawing on that red axis, on this axis here that's kind of in line with that red line. Now I've got my curve, I can select it and I can type pipe. And the start radius, I'm going to use my mouse to kind of guess at the start radius. I'm going to have an end radius that's slightly smaller. And maybe it gets a bit thicker here. There we go. And now I've got this quite complex shape that starts thick and then goes thin, 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 and then sort of like clashes out with the rest of the mug. You're getting some ideas about how you might model some things on your desk. I'm going to get like inundated with mugs now. Don't do a mug. Try something more complicated and more interesting. However, there's a bit of a problem here, which is that these handles are just kind of like clashing through the side of my mug. So this is a perfect place to use the same techniques that we used last week, which is our Boolean operations, where we can start to kind of carve out one thing with another. So in order to use Booleans, these shapes need to be what's called closed. So this is a closed polysurface. The reason it's closed is, the reason I'm sure it is closed is because when I made this pipe, I made sure that there's this thing called cap, and that puts a cap on the end of my pipes. I could actually do a round cap, which is kind of fun. I'll just do a much simpler pipe here. There we go. And this will kind of like put a rounded end on my sort of worm clay shape. There we go. Looking at this is probably a little bit high. Maybe I just want to bring that down a little bit. And do you see, I don't need to worry too much about that curve that gave me the thing. I can just sort of like start to model this with a little bit more freedom. Now, what I could really do with is using this cup to cut off the bit that I don't want of the handle. Yeah? Because I don't need the bit that's inside. I did that like quite loosely, and now I want to start tidying up. So I'm going to select this guy and type Boolean difference, which remember is the crocodile operation. I want to take a chunk out of this thing using another object. I'm going to select surfaces or polysurfaces to subtract with, and I'm going to make sure that delete input is turned to no. Because if I turned it to yes, and I'm going to use this cup to delete some bit of it, then it's going to delete the cup, and I want to keep the cup, thank you very much. So I'm going to make sure that delete input is turned to no. Use this, press enter, and now here is one polysurface. It's sort of split it up. Here's another one. Oh, here's the original one. Actually, I don't need the original one. And then this guy here, you can see that this line is now perfectly matched up with my the surface of my sort of quite complicated curve. And I can also get rid of this little guy here and press delete there. And now I've got this really nice join in between the revolved surface and my piped surface. You'd be really amazed how many objects you can make with combinations of lofting, revolving, piping, and then the simple things that we made last week, like boxes and cylinders and cones and spheres. Basically, you can put all sorts of things together and then match them up and smush them together in a way that basically makes almost anything. If you want to get really fancy, we could also fillet this joint, because real cups don't have an exact 90-degree bend between one thing and another. So there are some people who have actually used ceramics, and they might be saying, hey, hang on, this thing is much more sort of fluid than that. Well, we can use a fillet edge tool. A fillet, all a fillet is basically two things that join at a right angle or like a solid angle, two straight lines. It's going to replace those with a nice curve that goes between the two. And you can fillet an edge of a 3D surface. Fillet edge. I want a radius to be, let's try 2 and see what happens. And select an edge to fillet, and I'm going to select this edge. This edge here in between the handle and the thing. Enter when done. I forgot to do something very important, which is these two are very still separate items. And I need to make sure they're the same item. So I'm going to do a Boolean union. Thank you very much. There we go. And now they are one and the same item. And now that edge is going to make things very, very happy. I'm hoping, at least, anyway. Yeah, there we go. So this is just one closed polysurface. That's what it is. I'm going to do fillet edge. Select this little corner. There we go. Look at that. And we've got this lovely soft line in between. So do you see how I modeled that? In my mind, I started with the biggest, most clearly sort of like big move I could make. And then I went to the details. If I'd started by trying to model this little edge corner, I'd be in a world of hurt. I could do the same for this over here. Fillet edge. There we go. And now this thing is going to look absolutely lovely. When I look at it in 3 dimensions, I can see that kind of like nice smooth corner. We could even do, I'll just do that. Go back to our ghosted view. We could even do something where maybe you want to put your thumb somewhere on the top of the mug, right? That would be nice, wouldn't it? If there was a little whoop, beep, a little thing to put your thumb onto. So let's go here and we'll do a little curve that kind of maybe starts like that and then goes down like that and then comes out like that. There we go. And then I'm going to pipe that. And maybe it starts like this and ends quite small. I'm going to use the round cap. I'm going to make the most of that. And then maybe it's quite thick in the middle, like that. There we go. There we go. So I've got there's a bit for my thumb to sit on. I mean, it's not very good, is it? But it kind of do. One of the things about it, though, is that it should really be a bit more flat. So what I can do is I can come into this view and I can use my scale tool and I can scale this just in 1 dimension. So I can sort of flatten it out like this. There we go. And then similarly, what I want to do is make sure that these 2 things, where they coincide, I want to just make them one object. So I'm going to do a Boolean union, and it's going to smush them together. And then I've got this horrible, sharp curve that actually never happens in real life. So I'm going to fillet that edge. And there we go. Now we're looking at something that's kind of got something going for it, right? And if I really want to impress some people, I'm going to go to my artistic mode and I'm going to say, hey, look at this. And I want to show this off to someone. How am I going to show it off? Well, it'd be nice if I didn't just have to show someone my Rhino screen. Actually, that's a sign that you're not really in control of the process, because it would be good to have something that you can now export, put it in a folder, and it becomes part of your portfolio. How would we do that? Well, Rhino has a really useful little command, and you can type -view capture to file. -view capture to file. The hyphen just means that it's going to give you a whole load of options after this command. But view capture to file. I use this all the time. View capture to file is basically the solution to you having some stuff to put in your portfolio. Just every half an hour, save and take a screenshot of what you're up to and save it all in a folder on your Google Drive and back it up somewhere. Because then you've got a record of everything that you've done. View capture to file. I'm going to click that and it's going to say, oh, well, you want to save a file name. How high, how tall, how wide do you want that file to be? Maybe I want the width to be 2,400 pixels and the height to be 1,800 pixels. Scale 1, lock aspect ratio, no. Don't want to draw a grid, blah, 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 blah. This is all fine. I could even go transparent background, yes. And then the background is going to become transparent rather than this gray color. And then I'm going to browse, click the browse button up here, and it'll ask me, where do you want to save this file? I will put it on the desktop because I'm far less organized than you, who will put it somewhere in your very organized Google Drive file system. Here we go. It's going to give it a view capture name with a timestamp. I'm going to press yes. It's having a little think. And then if I go to my desktop, where's view capture? Here we go. I'm going to open that up. And now I've got a picture. Oh, it's come out a little bit funny. That's probably because of the PNG. Let's try a JPEG instead. Transparent background, no. There we go. JPEG comes out a little bit better. But now I've got something I can save and put in a portfolio and show to a tutor that's like, this is what I want to show you, rather than opening up a Rhino file and sort of doing this for half an hour, which kind of is confusing to everyone. So I really encourage you to take those screenshots, much better than just using the snipping tool to screenshot, because you can also, this is much higher resolution. I set the resolution to be 2,400 pixels. So I know I've got a much higher resolution image here out of Rhino. Even though it's just a screenshot, it's a nice place to start. Right. Was that helpful? Does that kind of get you going on some of those things? And hopefully kind of help you not trip up on the things that I spent years learning. So what I'm going to do is I'm going to pop back to our Mentimeter. We've got 10 questions. Excellent. I'm going to have a quick look at these questions. Has anyone put anything on the Miro board? No, clearly not. We're going to have a 5-minute break, and I'm going to come back and deal with as many of these questions as I can in an hour. Is that all right? Okay, great. I'll see you in 5 minutes. 10:05. Let's go for that.